I haven't scared everyone away yet. How are things going for you? Did you do okay on the homework? Okay. Okay, if you could please turn in your assignment. I asked you to do 3 problems, and I would count it as a quiz grade. So just kind of group them up on your table, and then just kind of pass them. See if we can get them all to show up on this table. All right, we got them all?
Sir,
yes.
Before we start, can I say one thing?
Ask.
You sound like Nicholas Cage.
Okay. That doesn't sound like a question, though.
No, a statement.
Oh, okay. Yeah.
Because Isa told me you sound like Nicholas Cage.
I never said
That's
that.
funny.
I never said that.
You know what?
I feel just right now that you said that.
I've actually heard that before.
Huh.
I've had
I've never,
students say that.
And those Christians told me.
Yeah, well, yeah.
Oh, really?
All right. Are you all ready to begin this class for real now?
Yes.
Okay. So starting tonight, you will have your first assignment out of the book. So you'll be doing some problems out of Chapter 10, Section 1. All right? And those problems are on the schedule that's on Canvas. You know what I'm talking about? And remember, I have some homework solution videos up there also that can help you through the homework if you get stuck. All right, so here we go. We're going to start Chapter 10 called Limits and Derivatives. And the first section is an introduction to the limit. So what I'd like to do is go back to a picture I drew for you when we were doing the difference quotient. If you were taking decent notes last time, you should have a picture somewhere in there where I said that we were going to pick a point x, and then we picked some other point, x plus h, and it gave us these 2 points. And then the difference quotient was actually calculating the slope of this line. Does that sound familiar? I said, and the ultimate goal would be to try and move this point over to this point, which means we would have to somehow make this point move this way. The difference quotient is this, right? So one way that we could move that point, x plus h, closer to x would be to make h get smaller. In other words, like if this was, let's say x was 3, and let's say that the x plus h was 4, then what's h here? What's h for this one? If this is 3 and this is 4, then what's h? 1, right? What we're really doing is we're taking that 3, we're adding 1 to it to give us 4. If I wanted to get closer, I could maybe move it to, let's say, like 3.5, 3.5. Then what's h here? 0.5, right? And then if I want to get h closer, I can maybe go to like 3.1. And then what would h be there? 0.1 would be h, right? Understand? To make this point land right on top of the other one, I would have to let h be 0, wouldn't I? If I let h be 0, then these would be the same point, yes? But let's see what we get if we try and take this difference quotient and replace the h with 0. So I want you right now to consider replacing h with 0. And let's just see what happens. Wouldn't this just be f of x? Okay. And then we'd have minus f of x again. And then on the bottom, what would we have? H is 0, right? So what is f of x minus f of x? 0. And we get 0 over 0. And this right here is a huge problem. Because you're not allowed to divide by 0 in our number system, right? You've been told, hopefully, several times in your life, division by 0 is not allowed. It's undefined. Have you all heard that? Okay. So what we're saying is that if we have two distinct x values, two different x values, 3 and 4, 3 and 3.5, 3 and 3.1, we are okay to calculate the slope of the line. But if we try and make these 1 point, then we get this, yes? And it seems like we would never be able to get around that, but we can. We can actually still figure out what the slope of the line is at a single point. But it requires that we start to understand this thing called the limit. And if you really look at it, all of calculus is built upon this idea of the limit. All right, so that's what we're going to talk about today, the limit. Remember this 0 over 0. It's going to come up. It's going to come up quite a bit. And I should also just, while I have it up here, 0 over 0, this right here is what's known as an indeterminate form. All right, that's what it's called, indeterminate form. And basically, what that's saying is we can't really determine what the answer is. All right, it's indeterminate. We don't really know what's happening when we see something like 0 over 0. All right? All right, so here we go with the limit. And we're going to start it with a picture, because I think a picture really kind of helps illustrate things that are going on. And this may seem very, very basic and rudimentary as we begin, but trust me, it'll start to get a little more complicated. So I want you to consider the following function. And I'm going to start us out with a nice, clean function, 2x minus 4. All right? There we go. Now, could you graph this? Well, you took 1324, right? So if you took 1324, then you know that this is a line, and we can graph lines various ways. But one way we could graph it would be to, since this looks like y equals mx plus b, we could start out by going to the y-intercept. What's the y-intercept here? Negative 4. Negative 4 is our y-intercept. 1, 2, 3, 4. Here at negative 4, we put a dot. And then from there, we use the slope. And what's the slope of this line? 2. 2 over 1. So that means rise 2, run 1. So if I go rise up 1, 2, and go over 1, draw a dot, that's a second point on my line. And then I could connect these with a straight line, and I'd have my graph. All right, your graph doesn't need to be perfect, all right? All right, so I want us to consider this function. Now, some questions. What is f of 3? So what am I asking you to do?
Replace 3 instead of the x.
Yep, just replace x with 3. So we do that, and what do we get? 2, right? So 2 times 3 is 6, minus 4, that gives us 2. So that's a point on our graph, right? If we go out, 1, 2, 3. If we go out 3, we're going to go up 2. So that point's on our line, right? So far, there's nothing crazy here, yes? Everything's just as the way it would appear. What is f of 2.9? Well, that means I'm going to plug in a number real close to 3, right? 2.9. and we plug it in, and you might need to get your calculator out for this. And I heard some calculators coming out. I guess I'll get mine also. You may as well have it out for the day. So plug 2.9 in here, and then subtract 4, and what do you get? 1.8? Yes, 1.8? So that means that if we're close to 3, right? If we're close to 3, we get a value that comes out that's about 1.8. Now we know up here at the top one it was 2, right? I know that's really small, but you get it? All right. How about this? What's f of 2.99? Do you think it's going to be close to 2? Try it out.
I'm sorry, so what was this plug-in? I'm confused.
Pardon?
0.99
We're plugging 2.99 into this function. So we're doing 2 times the 2.999, or 2.99 minus 4, and I'm getting 1.98. You getting that? So isn't that's even closer to 2, isn't it? So it looks like we know that at 3 we're 2, right? When we were kind of close to 3, we were kind of close to 2. When we got even closer to 3, we were even closer to 2. Yes? Let's just do one more. What about f of 2.9999? Let's go with 4 nines instead of 3. I just skipped one there. So 2 times that, 1.999, 3 nines, and an 8. Really close to 2, right? So would you agree with this statement? For this function, as x, I'm going to write it down, for f of x equals 2x minus 4, as x approaches 3, the function approaches what? 2. Would you all agree with that statement? Yeah. Do you understand the statement? Okay. Now, I approached 3 by picking some values that were to the left of 3, right? I was picking some points here like 2.9, 2.99, 2.99, right? Really close to 3. Can you think of some numbers that would be close to 3 but maybe on the other side of 3? How about this? F of 3.1. Isn't that just on the right side of 3? What would happen if we plug in 3.1? Let's see what we get. You think you're going to have an answer close to 2? Let's see. So do it. What do you get? 2.2. So we're a little bigger than 2, aren't we? And does it make sense from the picture that that would happen? If you pick 3.1, you're to the right. You plug it in, won't you be a little bit higher? According to this graph, you'll be a little higher than 3, or a little higher than 2. So you'll be up here above 2. So 2.2 makes sense, right? Let's pick something even closer. Can anyone think of a number that's closer to 3, but on that side, not on the other side? Okay, 3.01 or 3.001, something like that. Let's go with 3.01. Plug that in. 2.02. Yes? So if I go back over here and look at this statement again, for this function, f of x equals 2x minus 4, as x approaches 3, the function approaches 2. When I say approaches 3, what we've seen is that it actually works. We get closer to 2 as we approach 3 from both sides, right? Either side. Doesn't matter which side we come in on. This side or this side, the function is approaching 2. Yes? So another way you could look at it is, imagine you were like a little guy walking on this little curve. As your x value approaches 3, right, as your x coordinate approaches 3, your y coordinate is approaching 2, right? So you're kind of getting closer and closer to 2 from this side, and as you come in this way, you're getting closer and closer to 2, but you're coming in from the top this time. Yes? I know that this may seem like duh to you, like, okay, got it, but trust me, you need to understand this fundamental basic before we can really get into the limit. All right, so right here, when I say approaches 3, I just want to make an extra note to this little star here. From both sides of 3, right? That's what's happening here. For this function, as x approaches 3, from both sides of 3, the function is approaching 2. All right. Now let's look at a different function. Let's look at something more complicated. I want us to look at 2x minus 4 again, but this time over x minus 2. Yeah, that's the one I want. Okay, everyone got the function? I'm not going to draw it for you. But here's my question. What does f of x equals 2x minus 4 over x minus 2 approach as x approaches 2? Question mark. You know what? Let's do 3, not 2. Sorry. 3.
You want us to just start plugging in numbers?
Well, I mean, yeah, that's what we would do, right? Okay, so let's work through it together, and then we're gonna figure out if we can resolve this question together. Then I'm gonna ask you another question that's a little bit more difficult. All right, so what's happening? Well, let's start by trying to guess as to what we think it might be. And so if we're going to be approaching 3, right, let's just try and plug 3 in and see what happens. All right? So my work here, what I'm going to do is, let's try this. Try, bless you, just f of 3, and let's see what happens. Well, what would happen if I plug in 3? On top, I'd get what? 2, and on the bottom I get 1, so I get 2. So it seems reasonable, right, that as we plug in, as we approach 3 from both sides, that our answer should get closer to 2, right? Doesn't that seem reasonable? But let's actually plug in a few numbers and see. So if you want, think about it as a number line. Here's 3. You know, we've got like our graph. We don't know what it looks like. But let's start approaching from this direction, from the left side. So somebody give me a number to the left of 3 that we can try in here that's pretty close to 3. 2.8? So if you plug that in, you'll have to get your calculator out and do 2.8 times 2 minus 4. So you get 1.6 on top, and then you divide by 0.8. You get 2 again. Exactly 2, right? Exactly 2. Interesting. All right. Let's try 2.9. That's closer, isn't it? So I'll let you plug that one in, and someone can tell me what they get. You got 2 again? I mean, that's not even approaching 2. That is 2, right?
Yeah.
It is 2. And the last problem is we got closer. It wasn't exactly 2. It was getting closer. Here it is 2, right? So that means in my picture, we know that at 3 we're 2, right? And it appears that if we plug in numbers over here, we're also getting 2. So doesn't it almost seem like it's like a straight line there? And then we could try some numbers on the other side, like 3.1 and maybe 3.01. Don't worry about it. I'll just tell you what they are. They come out to be 2 again also. So it turns out that on this side, you're also getting 2. So it almost seems like a straight, flat line, doesn't it? Yes? Okay. So to answer this question, could we say that as x approaches 3, it looks like the function is approaching 2? Yes? It is 2, but... So the answer is 2 to this. So there's a slight little difference between this one and the previous one in the fact that we kept getting 2 out each time. Now the profound question, if you could call anything profound in this class. Let's restart this same function, but I now want to know, what does the function do as x approaches 2, not 3? So what happens as x approaches 2? So what should we try first?
1.8.
Let's just first see if maybe we can plug in 2 and have a good guess as to what's happening. So let's try to plug in 2, and what do you get on top?
0.
You get 0, right? And on the bottom you get 0. Okay. Now, we have an indeterminate form, right? This is undefined. That means for this picture at 2, when we try and plug 2 in, it's undefined. Do you see that? When we plugged in 3, we got 2. When we got close to 3, we were still at 2. But when we try and plug in 2, something bad happens, right? So let's see what happens close to 2. So let's try something close to 2. How about 1.9? Plug 1.9 in, and what are you getting? You're getting 2, aren't you? Try something even closer to 2. 1.99. You're going to get 2 again. Y'all following what I'm doing? I mean, I'm cutting out the calculator part. Some of you are doing it, but you're going to have to trust me. When you plug this into that, you do get 2. And if I tried to do something even closer, 1.999, I'd still get 2. And if I come in on the other side of 2, something bigger, something like 2.1, right? That would be on this side of 2, coming in this way, I would still get 2. And if I tried something even closer, 2.01, I'd still get 2. And just trust me that no matter what we plug in other than 2, we're still going to get 2. So our graph looks like this. It's 2, and then it's 2 this way. So our graph actually looks like a flat line, right? With the exception that at 2, what? At 2, it's undefined, right? So we have this idea that there's a hole there in the graph. You following me? Now, why is this important? Why in the world do we care about the way this graph is behaving? Let's go back to that picture I had a second ago of this, right? And we had a point here that was x. And we had a point over here that was x plus h. And I'm asking us, is it possible to define the slope of a line at a single point? Is it even possible? And when we try it with the formula, we get 0 over 0, don't we? What this is demonstrating is that if you ever see a function where you get 0 over 0, yes, you may be undefined. It may not have a value at a certain point, but near it, it can have a value. And I think you maybe would be convinced, if I slide this point over here closer, I do have slopes of lines here, don't I? And as I get closer and closer, I'm actually getting closer and closer to some value. Once I get to that value, it disappears, but it's pretty close to something, right? And that's the idea of the limit, is that we are not going to ever be able to get around the fact that this is undefined. But we will be able to see that it is approaching something. It is a limit. It is approaching, all right? Okay, let's try something. Let's do something with this that you may or may not have seen when I put this up here. Did y'all see that you could have factored a 2 out? Did y'all see that? And do you see that if you factor out a 2, that the x minus 2's cancel? And what do you get as the end result? That this function really just spits out 2, right? With the exception that if you try and plug in 2, it's undefined, right? So we could have seen this kind of from the very beginning, if we would have done some factoring, that 2 is going to be an important value in our function. All right. Let me give you another one to consider. All right, let's do some notation. If you see this, x with an arrow going to a number like that, what this means is let x approach, in this case, 3. That's what that notation means. So from now on, when you see that notation, that means that you're going to be thinking about not being at 3, but being close to 3. And close is weird, right? Like close is a weird word. Like, am I close to you? Am I close to you right now? A little too uncomfortable? Right? So do you think I'm close to him?
It's all relative.
It's relative, right? Like I would say that we're probably close. But am I close to SeaWorld?
No.
I mean, relative to this distance, like SeaWorld's really far, right? But if you think about SeaWorld in my distance to the sun, am I close to SeaWorld relative to the sun? Yes, so close is a very abstract word. We have to be careful with it, and that's why in a class like this, we don't get too deep into this whole idea of close, all right? Like when we said 2.99, is that really close to 3? You could argue it's not. You could argue that it's really far away from 3. It's relative. But we are going to skip over that sort of logic. That's what you do more in like a traditional calculus class. All right, you ready to consider another function? All right, here we go. Let's take a look at this function. F of x equals x squared minus 4 over x plus 2. What happens as what? What is that saying? That's right. That's saying what happens as x approaches negative 2. Right? That's what that's asking you. What happens as x approaches negative 2? So what could we do to just try and take a guess as to what it might be? What could we try? Just try plugging it in, right? Let's just try this. Let's try to see what's happening if we plug negative 2 in. And we're going to run into a problem, aren't we? Because when you plug in negative 2 right there and you square it, you get 4, don't you? So you get 4 minus 4 and then over. And if you plug in negative 2 right there, negative 2 plus 2, you get 0 over 0, don't you? And so it's undefined. So we don't quite know what's happening as we get close to negative 2 right now, right? We don't know. What's a way that we could maybe try and find it? Pick some numbers, right? Pick some numbers on both sides of this, of negative 2, and just plug them in and see what happens, right? So be real careful here. I'm going to draw a number line for you. Here's negative 2. Let's come in from the left first. Give me a number that's to the left of negative 2. Be careful. Let's get kind of close. Again, close is relative. Negative 2.1 is a good one. Remember, this is negative 1. This is negative 3, right? So if we're on this side, it's actually negative 2.1, not negative 1.9. Negative 1.9 is on the other side, right? So plug that in, and let's see what happens. I think you're going to get like negative 4.1. Someone can check it. You have to square it, subtract 4, and then plug it in right here. I guess I'll do this one. You should get 4.41 minus 4 over negative 2.1 minus 2. So this is 0.41 over negative 0.1, which gives you negative 4.1. Wait a minute, hold on. This is plus. This is plus, 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 plus. It's plus right here. I just wrote it down wrong. Plus. Yeah, that would have been something different. Okay? Yes? So right now, do you have maybe a guess as to what it might be approaching as we approach negative 2? Maybe negative 4, right? Maybe negative 4? So let's try something even closer. How about negative 2.01? And we plug that in, and let's just see what happens. You should get 4.0401 minus 4 over negative 2.01 plus 2. You should get negative 4.01. Do y'all understand what I'm doing with this? Plugging in? So do we feel stronger now that maybe it is approaching negative 4? Like we were pretty close to negative 2, and the function was spitting out negative 4.1. We got even closer to negative 2, and the function got even closer to negative 4. Yes? But doesn't this seem very tedious and kind of a pain in the ass to have to do this? Like then go on the other side and try the other side? Yes? So we actually could have got this result faster had we just done a little bit of algebra on this function first. So we would start the problem out as follows. We want to know what's happening as x approaches negative 2. We try negative 2, we get an indeterminate form. You see that? And instead of doing all this, here's what I want you to do. Go back to this and see if you can do any algebra on it first. So do you see something there in the numerator? Does this look like something that you should know? X squared minus 4? X plus 2, x minus 2, that's called a difference of squares, right? So in your factoring, we know that numerator is x plus 2 times x minus 2, right? And then the denominator is still x plus 2, right? And then what happens? X plus 2's cancel, and now you're left with just x minus 2, right? Now ask yourself the same question. What happens as x goes to negative 2, but plug it in here after this stuff is canceled out? And what would you get if you plugged in negative 2 into this? What's negative 2 minus 2? Negative 2 minus 2. Negative 4, right? And isn't that what it looked like it was going to? It's not a coincidence. I mean, that's the way we're going to do it. But it requires that we did a little bit of algebra first. Do you understand that? Now, the reason I showed you this is because we still need to understand what we're doing, okay? What we're doing is we're trying to figure out what's happening to this function as we approach negative 2. At negative 2, it's undefined. But if we draw this picture, it's actually going to look like this. Does this feel a little calculus-y to you? Like it's a little weird? Okay. So here's like kind of a summary of what I was able to extrapolate from this function in the question. All I can say is this. If I look at this function right now and I go to -2, I have a hole in the graph, okay? Because it's undefined, right? But as I approach -2 from both sides, what is my function's value approaching? What is it approaching? -4, right? So if we were to look at this graph, here's -2, here's -4 down here, right? I know that at -2 I have a hole. But as I come in from this side, it's approaching -4, and as I come in from this side, it's approaching -4. You following me? I don't know what the rest of the graph looks like, but this is what I can tell you. As I come in from both sides, I'm approaching -4 because of this algebra and then plugging -2 into that x. Make sense? Okay. We're going to do more examples, don't worry. I need to give you a definition, though. So let me define the limit. The limit of a function f of x is a number, capital L, such that as x approaches a, we have f of x approaching L. I know that looks weird. If the limit exists, we write LIM, underneath it, x with that little arrow to a. Then we write f of x equals L. What? Okay, I know this is real mathy, right? Let me just now go back to the problem we just did. For example, if we look at that function that we just investigated, we knew that as x approached -2, this function approached what? -4. So the way I could write that using this notation is as follows. I could write the limit, what was x approaching? X was approaching -2, right? The limit as x approaches -2 of the function x squared minus 4 over x plus 2 is equal to -4. That is the notation that we would use to represent all the ideas I just put on the board for the last problem we just did, right? We would write, okay, hey, look, we're going to let x approach -2. This is the function we're going to do it on. And what we found out was that equals -4, all right? Just be careful because this right here, what was f of -2? What was actually, if we tried to plug -2 in, what did we get? 0 of 0, right? So does not exist, right? Undefined, if you want. You could say undefined. So this is the big difference, all right? If I were to try and summarize everything I've been trying to put up here, is this. In college algebra, or in 1324, when we looked at functions, we always just took a number and plugged it in, right? Took a number, plugged it in. Took a number, plugged it in. Here, the calculus perspective is we put on a different set of goggles and we say, okay, instead of plugging in a number and figuring out what the answer is, we want to know what's happening close to a number. Close to it. Not at it, close to it. And that's what's going to allow us to slide that point down on the difference quotient and get a slope of a line, is by looking what's happening near it as opposed to putting the point right on top of the other one. Okay, I want us to switch gears. We'll get back to this, we'll do more, but I want us to switch gears by talking about limits. But what I'm going to do is I'm going to give you a picture, and I want you to tell me about the limits of this function. So I'm going to start off with the graph. I'm not going to give you the actual function, like f of x equals this. I'm just going to draw it for you. And then I'm going to ask you to give me some limits. All right? Okay, so graphical approach. All right, here we go. First example. Now, you do not have to copy this down like perfectly, but there are certain things that you do need to make clear in your notes, like how many units I'm going in each direction. But you don't need like graph paper and colors, and you don't have to get all fancy. Okay, there's a little grid for you, and now I'm going to draw a function in here. Here we go. Okay, take your time to try and do your best to draw that. Now, these are intentionally left as little open holes, okay, as opposed to the solid dots. What you see in front of you is the graph of some function which I'm calling f, all right? F or f of x if you want. That enough time? No? First question. Find f of -2. So this question is saying, hey, look, when you go to the x value of -2, what's your y value?
2.
So I go to my x value -2, and it looks like my y value is up here at 2, right? So f of -2 is 2. This is not a calculus question. That is an algebra question. All right? Now let me ask you the calculus question. Find the limit as x approaches -2 of this function. So what you're going to do now is you're not allowed to look at what's happening at -2. Okay, it's almost like you have to imagine that you're blind and you're not allowed to see what's happening at -2 anymore. And you're only allowed to look as you get close to it. So can you tell me, if I were sitting here walking on this function from the left side approaching -2, what my y value is approaching? So how high am I approaching? 2, right? And then what about from this side if I start walking up? 2. So doesn't it appear that from both sides, as I approach x is -2, my y value or my function is approaching 2? Yes? Okay, that's the answer. No surprises there. Let's look at the next question. Find f of negative 1. Undefined? Why are you saying undefined? Because of this hole, right?
Yeah.
Okay, but you see how I made this one solid? That is to help you see that, yes, it is undefined here, but the function does have a point somewhere. So that means, that open hole means there's nothing there, okay, at negative 1. But I have a solid dot here, which means the value is 2. Do you all understand that? Sure? So f of negative 1 is 2 here. All right. And now the big one. Find the limit as x approaches negative 1 of the function. So this was an algebra question. The algebra question, part C, said, look, just look at negative 1 and look for a dot somewhere, right? Part D says you're not allowed to look at negative 1. You have to look from the left and from the right and see what your function is approaching. Any ideas? Or any confusion as to, there should be something bothering you here. What do you got?
I can't understand.
You don't know what side it's asking for, like from the left or from the right?
This is not saying, yeah, this is not saying left or right, right? It just says what happens as you approach negative 1. But why do you care? You seem like you care, left and right. Is there a reason?
Yeah, because there it's sloping down.
Okay, because it's different from the left and from the right, isn't it? Okay, so look, if I'm sitting here, I'm not really allowed to look at negative 1. I don't care about that dot anymore. And I imagine myself walking along here, and I'm not going to negative 2 anymore. I'm going to negative 1, right? So I go up over this little hill, I come down. Now, what's my y value approaching? So what's my height approaching as I come down towards that point? It's approaching 1, isn't it? Isn't it? From this side, it's approaching 1. But over here, if I'm walking towards it, what's my y value approaching? 2. It's different from both sides, isn't it? From one side, it's approaching 1. From the other side, it's approaching 2. Now, why don't I care about walking out over here? Like, why am I ignoring this over here? Because I'm asking to be close to negative 1, right? Negative 1's right here. So I really don't care what's going on over there. Only close to negative 1. So we run into our first real problem here. And that's, it looks like we do have a limit, but from the left, it's different from the right, isn't it? So I need to somehow let you know, when I'm writing this limit, which side to look at. All right? So the way I can do that, and this is going to be new notation, I'll define it in a second, but I wanted to give you a visual of it first. What I do is I put a little plus sign or a little minus sign here above this negative 1. I'm going to do a little minus sign here first. Which side do you, by putting this sign here, it's actually asking you to only consider one side of this. Which side do you think the little minus sign means? The left side. Okay? That means, because aren't the negative numbers over there? Okay, and the positive over here? So this is really telling you to, look, tell me what happens as x approaches negative 1 coming in from the left side of the function. So what did you tell me that was if we're coming in from the left side? Going negative 1? You said the function was approaching 1, right? So that would be the answer. It'll be 1. Why did it not matter on this one? Why did it not matter which side we were coming in from? Because they were both going to the same place, right? Okay, so it really didn't factor in. Let's look at the next question. E. Find the limit as x approaches negative 1, this time from the right side. So I put a little plus sign up here. And that one's going to be 2. Because now we're coming into negative 1, but we're walking this way, and that y value is approaching 2. Are you all with me on this? Okay. What do you think the next limit I'm going to ask you is? Or what point do you think I'm interested in now? We've done negative 2. We've done -1. What do you think I'm going to look at next? 0. I'm going to look at 0. Something weird's happening at 0, isn't it? Okay, so let's try that. Part F. First, let's ask the algebra question. What's f of 0? 0. Because you have a dot there, don't you? So at 0, your function is, the height of your function at 0 is 0. So that's the algebra question. Now, let's ask the calculus question. What's the limit as x approaches 0? Now, is the left and right going to matter here? No. Do we go to different places from the left and right? If we're approaching 0, here's 0, right? If I come in from the left, what am I approaching? 3. If I come in from the right, what am I approaching? 2. So the left and right do matter here, don't they? So let's come in from the left first. Come in from the left of the function. What did you say it was? We're headed up towards 3. Next question. We're approaching 0 this time from the right, so I put a little plus up to the top right corner. And that's approaching what? 2. Does that kind of make a little sense? So we have this new concept that when you have this limit, that it is possible to talk about coming in from the left and the right like separately. So I think we need to kind of define that. So I'm going to erase this, I'm going to define it, and then I'm going to give you a picture, and I'm going to let you sit there and try and work out all the questions I'm going to ask, and then we'll talk about them, all right? So you'll be able to work on it on your own. But first let me define something. Left and right hand limits. We have this notation. This right here means as x approaches a from which side? If I have a little negative there, from left, then f approaches L. That's called your left-hand limit. And then if you write limit as x approaches a and you put a little plus on the top right, this means as x approaches a from right, then f approaches L. Left-hand limit, right-hand limit. Two separate concepts, all right? Last little definition. If we write limit x approaches a of f of x equals L, so if I write this down and I don't put a plus or minus here, then what this is telling you is that from the left and from the right, they go to the same place. Okay, so writing this means as x approaches a from both sides, f approaches L. All right, now I know that's a lot of notation and stuff, but let's do a problem. I'm going to draw the picture and then ask you a bunch of questions and see if you can make sense out of it, all right? Are you all doing okay?
What does L mean?
L is what it's approaching. So remember we were going like from this side, it's the height of the function.
Is that a business calculus term or?
No, L stands for the limit. That's where it's headed. It's headed towards its limit, right?
L. What is this?
Part what? Let's work through this example, and I'll let you all talk to each other, and I'll answer questions if you have them. I mean, sometimes the best way to like sort things out in your mind is to actually get in there and do a couple of problems. Yes? What about it? Yeah, it's all on camera. Yeah. I can write it for you later too if you want. All right, here we go. Take a moment to draw this picture. All right, here, I'll draw it in here. So let's go. So each one of those tick marks is 1 unit. Maybe, I think, these are the first 4 questions. I'm actually going to ask you 12 more questions, but maybe we can work through these first 4 together, and then the next 12 I'll let you do on your own. So let's see. Let's just go around on tables. So you can only answer if I've called your table. Anyone at the table can answer. So we'll just start out here with group A. Someone want to tell me what f of negative 3 is? One? Everyone agree? Anyone disagree? So all you're doing is going to negative 3 and trying to find where the dot is on the function. And the solid dot's right here at 1. Close enough? My drawing's not that great, but yes? Would we all agree with that? Okay, f of negative 3 is 1. I agree with that. Okay. Next group. We'll just go back to this table. What is this asking?
What is x as it approaches negative 3 from the left side?
So what's the function doing as we approach negative 3 from the left side? You want to take a shot at it, anyone? One. Okay, so look, again, we're going over to negative 3, right? And we're approaching from the left side, and we're walking along the function, right? And that function is headed towards 1, right? So the answer here would be 1. Okay, next table, back here. What's this part C asking us? Anyone?
What's the limit as x approaches negative 3 from the right side?
From the right side, okay. And do you know what it is? Negative 1. So now again, we're going to negative 3, and we're walking along the function from the right-hand side towards negative 3, and our y value is what we're looking for, and that looks like it's approaching negative 1. Now, do we actually get